Alright, so we just solved problem 5, part A, with new information, 36 meters per second at an angle of 30 degrees for the maximum height. And I want to go ahead and find the following just before the stone hits the ground. So what I'm going to do is say I've got my final velocity here, but or my final height here, but that's this up here. That means practically nothing to us when we're looking at this part. So for this, I'm going to get a different colored pen here. I'm no longer looking at the red box that we marked earlier. I'm now looking at this box from here all the way to the end. So I'm looking at the whole problem. Alright, I'm not going to use anything with that little top part. I also can't find the time to the top part and then multiply by 2 or anything, because this mirror is only up to this part here. It doesn't mirror from here to here. So if I found halfway time-wise, it would be sometime in here where it's not its maximum height. We're not going to do that. So if I want to find the following just before the stone hits the ground, remember, it is not going to ever hit the ground at 0. There is no physics problem occurring if that's happening. Okay. So what I'm doing is saying Vx equals, I'm going to answer for Vx, Vy, my resultant velocity, and then find the angle that it's going to hit the ground with. I found my initial velocity in the x direction up here, 31.18 meters per second. What I do know is that my velocity doesn't change in the x direction across the whole thing. So Vx, 31.18 meters per second. Alright. Part of the reason we asked for it in that question is so that we can go ahead and put it all in one place, even though we've already found it. You should know that it doesn't change and kind of rewrite it anyways. Now to find Vy, I'm going to say Vyf. I'm going to put question mark. I do not know what that is. I'm going to use some of the same things we did up here. Acceleration is negative 9.8 meters per second squared. Time, unknown. Velocity initial, I do know that at the very beginning I did fire it up into the air. Well, the vertical component of my initial velocity was 18 meters per second, so I'm going to go ahead and carry that in. I do not know Vf, I got T and delta Y. So I can say that Y initial in this case is 27 meters, Y final is going to be 0 meters. I know that delta Y still is Yf minus Yi, so I'm going to go ahead and do that again, equals Yf minus Y initial. This time I'm going to find it to be negative. So final is 0 meters minus 27 meters means that delta Y is equal to negative 27 meters. So if we want to find Vyf, we must include that one. I'm going to mark acceleration because it's there, mark initial velocity because it's there. I'm going to kind of dot through these because rather than use those, I'm going to use delta Y. Alright? So what that means is I'm going to use the one that does not have time. The kinematic equation without time is the third one, which is Vf squared equals Vi squared plus 2a times delta Y. Vf is what we're looking for. So I'm just going to say Vf squared equals my initial velocity is 18 meters per second squared plus 2 times acceleration due to gravity is negative 9.8 meters per second squared times delta Y. We know delta Y is negative 27. Alright. I'm going to go ahead and change those right now because I know that they are going to cancel each other out. Okay. So I have I squared 18 previously? I have it. It's 324 meters per second. We can see that right up there. So I'm just going to go ahead and say Vf squared equals 324 meters squared per second squared. Plus, I'm going to go ahead and multiply all that stuff out. Two times 9.8 times 27 gives me 529.2. Alright, and then checking our units, which we included in here. Meters times meters is meters squared. Seconds squared stays in there, so meters squared per second squared. So these units match up with each other. I must be able to add them. So VF squared equals 529.2 plus, I'm just going to go up there and find 324 just to make sure it's the same thing. Enter. There we go, 853.2. So equals 853.2 meters squared per second squared. I'm not done with the problem yet. I have to take the square root of that, so VF is equal to 29.21 meters per second. I was going to say 29.2 meters per second. Alright, and that's my final velocity within the y direction. If you guys want to keep track of everything over here, you can do that. Vy equals 29.2 meters per second. Note, this is not the answer that should be found on the homework because they're different numbers. So at this point, I'm going to go ahead and draw my triangle here. There we go. I know that it's moving to the right and down. So I'm going to draw my triangle first, the x component, and then the y component. Alright, and I'm probably going to find somewhere pretty close to 45 degrees because my values are about the same on this one. So Vy is 29.2. That is pointed downwards. I do want to note something actually right here. So Vf squared is equal to this. Technically my Vf final is going to be negative in the y direction because it's pointing downwards. So I do need to include a negative sign here if I'm just writing my velocity y. If I'm drawing the arrow, I know that it's pointing downwards. So technically I messed up because I forgot that in that part. But when I get here, I should notice that. So there's my angle, right? 31.18 meters per second is my x component. I'm just going to put 29.2 meters per second here because I do have the arrow indicating direction already, so I don't really need to worry about that. So I'm looking for that velocity right there and that angle. To find the velocity, I'm going to say velocity equals, I'm going to put it all together, 31.18 meters per second squared plus 29.2 meters per second squared, and I'm going to take the square root of that whole thing. Alright, I'm going to punch all of that into the calculator because I can, and it's going to look like this. Second square root of 31.18 squared plus 29.2 squared. That's going to give me 42.72. So V equals 42.72 meters per second. That is my resultant velocity. If I check the initial velocity that it was fired at, it was fired into the air at 36 meters per second. It should have a higher velocity when it hits the ground because its velocity right here would be 36 meters per second in the opposite direction and everything. Down here, it will have gained velocity in the y direction at that point while keeping velocity in the x direction. So I would expect to get a larger velocity, like 42.72 meters per second. The very last thing I'm going to do is find theta. In this case, theta is equal to the inverse tangent of 29.2 over 31.18. In some of the previous problems, we already had to work out. We went ahead and solved those out, so I'm not going to go through the theory behind that. We're going to put this in the calculator and say second tan negative 1, 29.2 divided by 31.18, and that gives me 43.12. So my angle, as long as I'm in degree mode, is 43.12 degrees. And I'm going to call that negative since it is going downwards.